All right, so this example, we have two inequalities that we're going to be graphing. So that means two different lines where we want to identify one set of solutions that both equations have, or solutions that both equations have in common. All right, so let's look at the first graph. X is less than or equal to -3. Let's look at that one. Well, first of all, we're going to have a solid line. Then we're going to sketch the equation of x is equal to -3. Now this is where you can't find a y-intercept because it does not exist, but we can make a table of values. Make a table of values. And then we want to determine which side we're going to shade. Okay, so going back, what if we, for the x coordinate, we plug in, for x, we said we plug in -5. Is -5 less than or equal to -3? That is true. Okay, so we're going to shade that side. Um, just hold off for a second because I want us to work on the second equation or inequality. So our second inequality, we have y is less than 5/3 x plus 2. So because it's less than, we have a dotted line. We're going to graph y is equal to 5/3 x plus 2. Here because it's y equals, we can find the slope. Rise 5 units, run 3. Our y-intercept is at 0, 2. And then we're going to use a test point, 0, 0. Go back to the original inequality. Substitute 0 in for x and for y. So it's 0 less than 2. That is true. All right, so we have everything that we need to make these lines. Now, x equals to -3, okay, is going to be a vertical line at -3. So let's go ahead and graph that. Here is -3. We have a solid line. Okay. Now, here's our test point right here. Excuse me, I'm sorry. Our test point is at -5 on the x-axis. Here is -5 right here. I'm pointing to it. It says I'm going to put a small t here. What this is saying is that right here at -5 is true. That means if it's true where I'm pointing to at -5, then everything to the left of this graph is all true. So hold off on that because our goal is to find out where both of these are going to intersect at. Now let's look at the second equation. We're going to start at 0, -2. It's not -2, but 0, +2. We're going to go up 5 units. 1, 2, 3, 4, 5, and run over 2 units, excuse me, 3 units to the right. 1, 2, 3. Okay, I'm going to go in the opposite direction, go down 5 units, 1, 2, 3, 4, 5, and then go over 3, 1, 2, 3. So we have a dotted line. All right, so it says here at our test point, which is 0, 0, is true. So imagine that this blue line was not here. Our only focus was this green line. That means everything below this green line is true. So let's determine where would both of these lines have the same solutions. Okay, or both of these inequalities will have the same solution. So here, I'm going to use a pencil. My blue line, or our blue line, okay, this is where it's all true. But our green line, where it's all true, look at how I'm shading where the green line is at. Do you see where it's intersecting any place? I see this area right here that I'm going to color in purple. This would be our solution. So that is our answer right there. We want to find out where both of the inequalities intersect, and it's this small region right here.